Hello everyone, welcome back to our Spring Boot series. Today I will be talking about how to call a stored procedure using JDBC template, but there is a little bonus that I'm providing at the end. In our code walkthrough and due to some limitations that H2 database contains, I will have to use the MySQL database. And for that, I don't want to install the database on my system because in these videos, I like to provide a real dev environment. So we don't have to install other servers in our machine. But for that, I advise you have to install Docker because I will be using something called TestContainers with just a few lines. And I promise you that with just a few lines, you can start as SQL server like MySQL, inject some database like a schema and data, and use it as a regular database inside your Spring application as if you were using the H2, which is a great thing. So you can add any database to your application. The only requirement is for you to have Docker installed on your machine, or maybe Podman. I think it should work also. So, but let's start with our regular stored procedure call using JDBC template. So what is a stored procedure? Usually a stored procedure, you can see it as a kind of a method like you do in Java, but written in SQL. And it changes from server to server, but at the end of the day, the template or the model, it's quite similar. It's just you write something like create procedure or create or replace procedure or create procedure if it does not exists. There are some variations, but at the end of the day, you just write something to say, I want to create a procedure. You give a name and parameters like a regular method. And then you have a way to provide a begin and end. Sometimes you have the words begin, and then other times there are some delimiters. But if you follow the SQL standard, usually it should be very similar to the one that I'm providing here. Now you can have these parameters. These in usually are optional. By default, all parameters are in, but you can also write the word out, meaning that you can put some data here, like for instance, this sum, and the result of this sum will be provided by this out parameter that you can collect on your Java side. But let's see how can we do this in our Spring Boot application when we are calling stored procedures. So why do you want to use stored procedures? I will say to you, it's not a good idea most of the times, but sometimes they are necessary. Maybe you want to reduce code duplication. You have some, I wouldn't say business logic, but there are logic that needs to collect data from thousands of lines, do some count and sums, and take this data and relate with other records on the database. And doing this in Java, it's not only slow, but it will be a lot of code that should be, of course, in the database because you are doing something on the database. Of course, you will be paying a price, and the price is that this data, this business logic, will be hidden from the code. Because usually in the code you have the Java, you have this on Git, maybe you have SQL, but people usually don't look into the SQL when they are looking into the code. They say, okay, the SQL, it's the code that we use to insert and update data. Even when there are stored procedures, it's not common for a developer to read the SQL at the same time they are reading the Java code or C# or Python or any other language. That's why it will be hidden, and it should be taken with some care and very well documented. Highlight on your GitHub or other systems, say, okay, there are some business logic of this application in the database. Please, before changing something on this class, for instance, take into consideration that there is data, there is stored procedures doing some business data on the server side. That's something, that's the price that you have to pay. But there are big advantages. It's faster to execute on the database if you are only working with the data that is on tables. There is no network traffic. I put it here lower, but it's less than lower because it's already on the server. Regarding security, only people that have access to the database can execute that stored procedure. It's very close to where the security is implemented. If you implement, of course, security on the tables of the database, and it can be reusable by different applications. That's true, but please don't do it. Never do it. Avoid at all costs. And as an architect and with experience in big companies, one of the biggest challenge every time we have when we are refactoring applications is to understand which applications are using a specific storage procedure. And if you have multiple applications and multiple teams, it will be a nightmare. Or you have a great documentation, a guide that controls all the documentation, the reference. Otherwise, it will be a nightmare. Everyone will have afraid to remove the storage procedure. So I put it here because everyone thinks about it as a good idea, but from my experience, it's the worst idea that exists. In code, yes, great methods to be reused by other components. In the database, it's preferred to copy paste the storage procedure with the same logic in different schemas and put on the name, say, this is for the application A, this is for application B, or maybe create a storage procedure called some belongs to application A and inside call the other one that it's called application B. At least you have a control who is using what. And maybe it will be a good idea to create different users and link or bound these users to the store procedures. In this way, you are making sure that you have a kind of a very low level data level, that database level layer on the architecture on the database, and that is an extension of your application. Meaning, if you have three applications that need this store procedure, they both will have, all of them, they will have a copy of the store procedure, even if that the copy, it's not copy of the code, it's calling the other store procedure, a common one, but at least you have a reference for that. Otherwise, it will be very difficult. You have to do some search and find in your repositories on the source code to check who is using this store procedure. And we hope that because I already saw this before, that the name is not generated on the code with concatenations, things like that. So avoid it at all costs. So JDBC template, a quick review for those it's the first time. It's a way to abstract the JDBC, the regular JDBC, from access to database, and simplifies queries, common queries, and repetitive code like open connections, open ResultSets, and things like that. It makes our life easier. There are other tools like Hibernate, JDBC client that I will talk in other videos, but usually I'm giving a lot of time on JDBC template because there are a lot of legacy code that use JDBC template. And sometimes JDBC template, it's a really nice addition if you need performance to do inserts, updates, and deletes, and it's much better than Hibernate. Hibernate, it's great for relations, inserts and updates, CRUD operations, but for large amounts of data, maybe you want to use JDBC template. So let's go to our store procedure. Let's call it raw store procedure calls, the raw way without any tricks here. The theory. So use JDBC callable statement. This is the statement that you should use when you want to call a store procedure. The name it's already saying callable statement. It's not a prepare statement. It's a callable statement, meaning that we will call something procedure, but there is also the option to call functions. Some database support both, but the way to execute it's the same as the other ones that we saw in other videos like JDBC template execute, and this is the common pattern on the code. So your JDBC template execute, you write with these curly braces here, they are necessary, call procedure name, and then you have these question marks indicating the parameters that you want to bound to this store procedure. And then there will be code here that I will explain in a moment. And by the way, this T will be the return type that you want to return as usual on the JDBC template. So there is, as I was saying, there are procedures and functions. There are some syntax difference. They are quite similar, but the only difference is that functions should return a value. It's not normal for a store procedure to return a number. There are some store procedures that allow you to do a return, an integer. That's the only thing that you can return. We'll see an example where you can return a result set, but usually in modern ways, usually the functions are replacing store procedures for that purpose. But what I'm saying is a procedure was the first thing that appeared on database. So it worked as a kind of a void methods, but you could return result sets and integers and even output parameters here. But currently most of database support functions. So most of the things you can do it with functions. Functions go one step further because you can use functions, for instance, in queries like select from where, and you can call a function there. But for instance, you cannot call a store procedure. But you can, what I'm saying, avoid returns on store procedures. They will. It's possible. I will show you here in a moment. But you will have other elegant and modern ways to do it using functions. But the difference here is this question mark. This will be seen as a first parameter, not a return. There is no concept of return in JDBC template, only parameters. And you can see from the question mark. So this will be the first one, this will be the second, and so on. And in this case, the first one will be this one. The question marks always indicates the parameters, whatever they are in the statement. JDBC template doesn't understand what is this call function. It's just that it will execute this on the server. So the main flow usually when you use this JDBC template, so you have your Java application, you prepare and set parameters on your query. That's the code that you will see. And we call the story procedure. There will be some return or output values, and you will see in a moment how to do this. And then we'll have the result. This result will be this part here that I show you. This block here will be the result. Okay, so step one, let's see with input parameters only. So imagine that you have this story procedure, call it greet. You have this input parameter. By the way, this in, it's not mandatory. By default, they are in, but I put it here so you understand. If you see it, you understand. And you want to put it if you have output parameters, at least to be readable. So you have this begin, select, concat, hello name, and it will display this if you execute the story procedure in a console. You can even treat it as a result set, and I will show you in a few slides how to do it. But the main idea is that you receive this parameter, and now you use it here as a regular variable like you do in Java. And how to use it on JDBC template, you just do it like this. You have this call greet with these parameters. This will be the first parameter, will be this name here. And then you write callable statement. You will return an object, whatever you want to return. In our case, you'll be returning null because we have no purpose on this code, but I will show some real examples in a moment. But again, this after it is executed, after the execution, you can do whatever you want with the date. Of course, you have to set here the parameter, the first parameter, one set string with Alice. So this callable statement is replacing usually the prepare statement. So this is a callable statement callback, meaning that it will execute the start procedure and then it will execute this code when you do this execute here. So now with output parameter, so we have add numbers, we want to add A and B, we want to return sum. We are using procedures, not functions. That's why we need this trick about the output. We don't want to put a return here. It's possible in some variants of SQL to put a return, but those returns are more about the status, meaning it went well or not. -1, it's error, 1, it's okay, and things like that. You don't want to use two business values like this one. So in this case, it's better for you to set, it's to sum, to sum those values and set on this variable sum, and this value will be returned to the JDBC template if you define as output parameter. And you can see here, you have these 3 parameters. These 2 are input, and then the third, you see that you write like this, register out parameter. And you should say the data type here, because you don't have a register int out parameter. You can see that here, you define the type on the name, but here it's just out, so you have to explicitly say here what is the type. Then you execute, and now you get the value after this execute that you expect to be on this third, which in our case will be the sum that should contain the sum of these 2 numbers. So we can get the sum after the execution like this, going to the third parameter. It's quite nice when you need, for instance, to generate numbers that are auto-generated and you are using stored procedures. It's a way to get them. Okay. Now with a return value, sometimes it's possible, but in this case, usually you go with a function. And using the function, you have a name, you have parameters, but usually you should see something like returns something. And there are quite advanced scenarios. You can have scalars here like int, but I saw places where you can return tables and things like that on the returns. For instance, SQL Server Microsoft, I know that it can do that. Even Oracle and the others, I'm sure they will accept here as return types things that are not regular values like tables and things like that. But again, rather than put the set or an output parameter, you just return the multiplication. And of course, the data type of this multiplication should fit the data type that we define here on these returns. And here on the execution, it's quite similar because at the end of the day, remember the JDBC template doesn't differentiate between stored procedures and functions. All of them are calls, callable statements. So the only thing that will change is the layout of this call. So here now we have a parameter that it's equal to this. So the return of this, the result of this call will be set here. So it's all about the same. So our first parameter here will be the output value because it's the first question mark. And then the second and third will be these ones because 1 2, 3. That's how it works. There is no function or started procedure here, just a sequence that matters. So 1, 2, 3, we execute and we get the value for the first from the first parameter, and we should see this return. Another one is what if we have multiple output parameters? It's the same thing. We have multiple, you put multiple parameters like out here, and then it's the same. Rather than register one, we are register multiples of them by the position, and we get the same way. In this case, we are just putting on a map and return the map, and that's why you should take into consideration to put here a map, of course, on this callback, which should be the same data type that we are putting here. So this one, and what we're returning here, all of them should match on the same data type. What about the result set that I promised earlier? So in this case, you have a startup procedure, get users, and you are doing a select from users. So it's like you do a regular query, but it's returning the result set. But by default, startup procedures don't return nothing. But the result set internally on the SQL any SQL server will create a kind of a cursor in memory, which in our side we call result set. So the first thing that we should do is to ask to the callable statement, is there any result set created after the execution of this sort procedure? And if there is, you can ask him, please give me that result set. So the return of this select, it's not a common return as a value. It's just a pointer or a reference to a result set that was created on the server, and you have access to it. That's why here we have this execute here for this callable statement, this call get users, which is this name. And now you can see that I ask to the execute saying, he has a result set. It's something that we can ask to execute and if that's the case, we can get it and treat it as a regular result set as we did before for other queries. That's one way for you to return result set. Some people don't like it. I have seen a lot of, in some banks I've worked on, that they don't do this. They put this data in a table, and then they execute the start procedure that works on some data and inserts all the data in that table. And then they know that that table should have result set. Some people say, okay, but the table will be shared with multiple executions. Depends. You can ask to the server to create tables associated with a connection or a session, meaning that when the start procedure is executed, it's executed in the context of a session. And you can say to create a table in the context of that session, meaning that only this session or this user can see that table, and then automatically this table will be dropped after the connection close. That's the theory beyond the SQL Server, but that's how it works. But I don't think it's a good idea if you have to create all these tables to thousands of users. Maybe this should be better. And if this happens a lot and there are no filters, maybe you should start to consider maybe to put this on a cache or something, and rather than execute the start procedure to get this data, just go directly and connect and get the data. Of course, there are things that you should handle. Now it's more about good practices. So always wrap procedure calls in try catch. You never know what can happen inside the start procedure that can break the exception, and you want to log that information. It's common good practice, not only for start procedures, but any other database operation. Transaction handling, if the start procedure should belong to a transaction, it works the same way as I explained in an earlier video about transactions. You just put this transaction, use it on the service level, don't use it on the repository level, because most of the times when you do a transaction, you want to do multiple calls in different methods on your repository classes. So you want the transaction to be at the service layer, not on the repository layer. It's not that you cannot put it there, but there is no reason to put it there, because by default, usually a simple call, it's always transaction in any database server. Limitations, it's quite verbose. You must register and set all parameters in the exact order. Error prone if DB procedure is signed to change. If someone changes database, your code stops working and you don't understand why, unless you see the logs, because there is no coupling between the code. That's the reason I explained earlier. If you create start procedures, they will be hidden in the cloud of the server. Now you have result sets that can only be processed sequentially. A database specific behavior like syntax types, it can change from database to database. The way start procedures work, and they are harder to mark or test. Some best practices, always document start procedure signals in code comments. And when I say comment, it's not only the start procedure in the code, comment also on the applications they use this stored procedure. On the method, say I'm using this stored procedure with this name. So you have a way to relate the stored procedure with applications that later can be really useful if you are refactoring your application or you want to merge your application. You are moving a monolith to a microservice architecture. Believe me, you want to understand where this stored procedure is used. Match parameter order type exactly. Of course, handle all exceptions and null checks. Use named constructs parameter index if possible. Meaning that if you have output parameters, rather than use one or two, provide a name saying this is the result or ID generated. Things like this is the sum. So it's just a constant that you have in the code in Java code, but it will be simpler to read what is the purpose of that output parameter. And of course, debugging common issues, mismatched parameters, count order. Most of the times, most of the errors will be because we are wrong about how we set. Maybe we change the output in the stored procedure and if we forgot to do it on the Java code. It's a quite common error. Using wrong SQL type on the register output parameter, not closing result sets, because since we are now controlling the result set on a stored procedure, it's not the JDBC template it's controlling, so we should close it, for instance, and ensure that the DB user has execute permission. But this kind of errors, I think they will show when you try to execute your code. In summary, and some key takeaways, raw JDBC template, full control, more code. That's one of the things. Master CallableStatement for flexibility. There are some use cases where stored procedures are great, but avoid at all costs, unless you have to perform operations that are faster on the database size than on the Java size. Mind parameter order and SQL types, of course. Exception transaction under are critical. If they belong to transactions, make sure that you put the annotation in Spring Boot. Know when to use raw versus higher level abstractions. There are other frameworks that you can use in Spring Boot. It's possible on Hibernate, but Hibernate I don't like it how it uses stored procedures. The JDBC client, it's quite nice because it's verbose and you explicitly say which parameters maybe they are better for you to use stored procedures. But this lesson was about JDBC template because there are a lot of legacy code using JDBC template. That's why I provided like this in the row level, meaning that you should write the call and the parameters with all the questions marks. If you want some reference, you can find here more information about the content that I provided here. So thank you. Now I will go to show you a code walkthrough. Again, as I promised, I will show you also how to execute a test container using MySQL and not the H2 database. So let's see, as I was saying, I'll be using test containers. Test containers, I will provide more details in a future video when I will be talking about testing in Spring Boot applications. But for now, a test container, it's a container that executes on Docker or Podman, for instance. And what it does is when you need a database, you just reference in your Spring Boot applications, I want a MySQL container. And of course, you have to provide this dependency. I'll explain in a moment. But when you provide this information, automatically Spring Boot will look for the container of MySQL, for instance, and will download it, install it on the Docker container, execute it with a username, password. It gives you the part, and you can at this time just provide a SQL, like create tables and things like that, and the server will be ready for you. You don't have to install it yourself. Everything will be done automatically if you just follow the steps that I will show you. So the first step for you is just to add these dependencies. The one is the org test containers. Of course, the first one it's the MySQL driver because we'll be using access to a MySQL database. So first we need to provide the driver. I'm using this one. And this is just MySQL related. It's not related with the test container. It's just MySQL. If you are using MySQL in your server, you should put this dependency. Now for the test containers, you will need both of these dependencies. One is the test containers, the regular core, which is the API that supports all the functionality about test containers. And now here you say, I will want a test container for MySQL, because usually the guys behind these test containers, they have already provided a lot of test containers for a lot of different services. It's not only databases, there are other servers that you can use. And this one is for MySQL. So the next step that we need, so let's say that we start our application Now we need to start this test container and provide a data source that you can use to create a table there. So for that, I create here this class, which is a configuration. So we can create bins. Remember that in Spring Boot, everything is a bin, and you only have to do something like this. Okay, and this code, this is the only code that you need to use the test container. It is as simple as you are seeing it. It's just this. I want a MySQL container, and of course you understand this one because of this dependency here. Okay, and now you say create a MySQL container. This is the version. I want for you to create a database named FinanceDB. This will be a completely clean container. You don't have to install it. It will be installed automatically. You just have to start the Docker first. Otherwise, you'll receive an error saying, I cannot find Docker on your machine. Okay, now you say, with this database, with this username and password, there are other things that you can provide here, like port, but usually it's the best practice is for you to allow the container to generate the other information, because you can get that information later if you need it. Okay. Now I create a bin, which is a MySQL database, because I don't want to conflict with another bin that I created for the other examples in the application that I'm developing for these videos, which is the H2. Okay, that's why I gave it a different name for this one, this bin, which is called MySQL data source. And this is a regular way to create a data source. And you can see here that I'm using this MySQL. I'm getting the address, the username, the password, and the drive name. It's just configurable as that. I don't have to know, because it will be generated and I'm just getting the information that was generated. It's quite elegant, quite clean. It's very difficult to error here. Now, of course, I will need a JDBC template to inject in my repository, and I want to target this data source, which, by the way, it's our MySQL data source. So this bin depends on this one, but this will be managed automatically by Spring Boot. And you have to, since now we are using test containers, it is your responsibility to manage the transactions. So by default, you should create this bin, so you are providing a transaction manager to the Spring Boot. There are other ways to provide those, but if you want to just to go simple, just to this one. So for this data source, I want to use this platform transaction manager. You only need to have this line. If you if you are using this application, you will need this one. If you are creating a new application, maybe you don't need. But since I already have an H2 database here, that can be problems. And in that case, you need to provide this platform transaction manager. Now I have to initialize my data. And here I create another bin, which is a component that I want to be created by Spring Boot, because it's a component. And in this case, I'm using this qualifier because I want to inject the JDBC template for the MySQL. Remember that I gave this name. I don't want the default JDBC template, because the default is JDBC template. And if you are following my videos, belong to this SIR here, which is H2 database. So in this application, we have two different data sources, one that already exists, but I wanted to add a new one for the MySQL, and that's why this JDBC template has a different name. So here I'm injecting, and I explained this in an early video about the naming the bins. So I'm putting the qualifier to say, hey, Spring Boot, inject here this data source, this JDBC template that uses the data source. The data source, it will be this one, okay, the one that is connected to the MySQL. Okay, and now after this is created and after everything is initialized, because to inject this one, it's necessary to create this bin, and to create this bin, it's necessary to create this one, and to create this bin, it's necessary to have this initialized. That's why this post construct, which is called after the bin is initialized, I'm creating a table called entities. That will be our example. It's similar to the table that I have on H2 database. And I will execute the drop procedure if it exists, insert entity. It's a common practice, only if it exists. Otherwise, just create a procedure, insert entity, which will receive a name and will output a generated ID. And in MySQL, you can do something like this. Just insert, and if there was an ID generated, you can get it using this function, last inserted ID. And it will be on this output parameter. Now we are ready to our repository. So in our repository that was created before, that manages CRUD operations on our database for specifically the first thing that I did was just to inject this JDBC template here. Okay, I need this one. I want this table, the entities repository, to be managed in a different database. So I'm using a different JDBC template, which is the MySQL one. As if you remember, it will be this one, the MySQL one, which is connected to this data source, which by the way, it's connected to the MySQL and not to the existing database. Which means that here I'm using the JDBC template here. I will do the call to the store procedure, insert entity, our store procedure, with two parameters. Okay. The first one, it's the name of the entity that I'm receiving here, that I want to create an entity like, for instance, a company, that Apple, because I want to buy an iPhone or something like that on our finance application. And I register an output parameter, which will be the second one, which will be the ID generator. If you see it, it will be this will be the in parameter, and this will be the ID generated here. And we execute, and I will get this int, I will set to this variable, and then on the entity that I receive to create, I expect the ID to be null. I will set the ID generator and I'll return the entity, so I can show now that I create the entity, and as a result, you can see the ID that was generated, similar to the way we did for other entities when we use prepare statement. And that's it. It is as simple as this one. So I added a new database, server database, with only these lines, and of course with these dependencies here on our POM. That's it. So let's execute this. I will start. In my case, it should be faster than on your side, because if it's the first time that you will be executing, it will install your Docker. In this case, you can see that it's already installed. So it's starting the Docker here, and you can see information about it if you look into what's happening here, and waiting to be started. And if we follow this code, you can see it started here on this port. It will be always different with the database that we provided here, and they even tested with this, so he knows that it's working because of this query. Okay, and the rest is the one that we already had in the past for users ID. So we have two servers running at the same time. So we take this one. Let's see if it's working or not. So I'm connecting here to the server, but I have to change here the port, because now it changes. In my previous test locally, it was this one. Now it is in another place. It's 6.1 user root. Tiers will be also root, because it's the username and password we provided. The finance databases, localhost. Let's test connection. Okay. Maybe I wrote wrongly. Root 6001, it seems. Let's test again. Test connection. Okay. So let's do okay. Let's expand. Database, it's here. Our table entities, it's empty. So we are now connecting to the server that's running under the test container, not the H2 database that we have, but I can have access to both of them. So let's execute some REST controllers, because if you are following my videos, you already know that we have a REST controller here that for each one of the entities, and the entities, of course, has some posts here and gets that you can, by the way, you can get this code from GitHub. I have an address provided for each one of my videos on the posts of the channel. So you can see there the address of the GitHub of this project if you want just to download, export, and execute on your machine. But this is a REST controller, and you can see that you have some post mapping for transactions and things like that. It's related with other lessons that we have in the past. But you can see here get, post to create an entity, that you create a service that will create our entity. Which, by the way, we'll call this insert entity and return ID. But let's execute it. So when I execute get all entities, it's empty. It's not expected because it's an empty table. Okay, now just post and create an insert, and you can see generated with ID 1. It was the value generated, and it was returned by this return, which was our output parameter. So this is working as expected. So let's execute again the get. So we can see that it's already there. And after the get, you can see that we have this one. If you don't believe, I'll just do another post and get, and you should see two entities, number 1 and number 2. So this is what I want to present you, how to call store procedures using this template. And by the way, you have a bonus about how to install a test container. I think it can be really useful for you if you didn't know about this technology that can facilitate a lot local testing. And when you want to test a specific database, or you need something advanced on your application during development and you don't have a dev environment with a specific database, or maybe you just want a controlled space for your data, it's great for testing, because when you have a development environment, you have multiple people targeting the same database, and there will be a lot of pollution, let's say, on the tables with data that you don't control. And test containers are always a great option. So this is what I wanted to present it. I hope it was useful for you. Share my video, share my channel. It's always a motivation for me to have subscribers and people that like what I'm saying. And I hope to see you in my next video. Thank you for watching.